Well, hey everybody, Mr. Reeves back with you again as we continue our investigation into linear non-proportional relationships. All right, so just a reminder, when you see that word a linear equation is an equation whose ordered pairs form a line. So when you plot those ordered pairs, if you get a line, it is linear. Now, it can be linear and proportional, or it can be linear and not proportional. And if you look here, it says linear equations can be written in the form y equals mx plus b. And when b is not equal to 0, the relationship between x and y is non-proportional. When b is equal to 0, then it is proportional. All right, so let me just take the time here to clarify a little bit. I'm going to put here at the top, I'm going to put linear. Okay, and then over here, I'm going to put in red proportional. And over here in green, I'm going to put non-proportional. Okay, so what makes the relationship proportional and what makes it non-proportional? All right, if it is proportional, then for any given ordered pair xy, y divided by x is equal to a constant, which is equal to k. All right, for a non-proportional relationship, y divided by x is not equal to a constant. All right? All right. If it is proportional, then the equation is going to be y is equal to kx. If it is not proportional, then the equation is going to be y equals mx plus b. If it is proportional, the line passes through the origin. And remember, the origin is the point 0, 0. And guess what? If it is non-proportional, the line does not pass through the origin. And again, the origin is 0, 0. All right, so those are all the things that are different. All right, but there is something that is the same. The change in y over the change in x is a constant. And guess what? For this one as well, the change in y over the change in x is also a constant. That's what makes it linear, right? That's what makes it linear, and that is equal to the slope, and that is equal to the slope. Okay, so they're both linear, and the reason they're both linear is because of this bottom reason here. So these are the things that are different. So when you're asked if it's proportional or non-proportional, take any ordered pair, and if y divided by x is the same every time, then it's proportional. Or if you have a graph, take a look. Does the line go through 0, 0? If it does, it's proportional. If it doesn't, it's non-proportional. Okay, so this is really important stuff for you to know. And again, we're moving into this non-proportional. Y equals mx plus b. We have that extra part at the end that is added. All right, and of course, sometimes it might be negative. So let's take a look at some examples. Okay, so we go back here, and they have down here at the bottom, Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation, and here's our equation. So we immediately know this is a non-proportional relationship, okay? If that minus 4 weren't there, then it would be proportional and k would be equal to 12. But that minus 4 part is what makes it non-proportional. Now, they didn't give us a number of hours, so let's go ahead and put 0, 1, 2, and 3 in, and let's find his earnings. Well, if he works 0 hours, but he still took the bus, guess what? 12 times 0 minus 4. What do we get? We get negative 4. What a bummer. He took the bus and then didn't work. He lost $4 that day. Now, if he worked one day, it would be 12 times 1 minus 4, and that would be 8. If he worked 2 hours, 12 times 2 is 24 minus 4 is 20. And 12 times 3 is 36 minus 4 is 32. All right, so you'll notice a couple things. This is a non-proportional relationship. And we know that because when we take a look at that. It does not go through 0, 0, right? It's not going through 0, 0. But yet it does have a constant rate of change. Each of these is going up by 8 as each of these goes up by 1, right? So y divided by x is not a constant. But change in y divided by change in x is a constant. And if we were to graph it, that would be the slope. That's what makes it linear. Okay? All right, let's skip over and take a look at another one here. All right, so here we have the equation y equals 2x plus 20. So the entrance fee is $20. Do you see how it's 0, 20 and not 0, 0? So immediately we know that this is what? Not proportional. It is not proportional. Okay, it doesn't go through 0, 0. And there's that reason why. That plus 20. Again, if it were y equals 2x, that would be proportional. Right? But the fact that it has that plus 20 makes it not proportional. Okay, but we can find these values. Here we go. If we put in 2 times 2, let's try to do this mentally, shall we? 2 times 2 is 4, and then we get 24. All right, 4 times 2 is 8, plus 20 is 28. 2 times 6 is 12, and we get 32. And 2 times 8 is 16. Plus 20 is 36. All right, so again, if I were to take a look at y divided by x, well, this one right here is 24 divided by 2. That's 12, right? But if I do 28 divided by 4, what do I get? I get 7, right? 32, 6 doesn't even go in evenly, and 8 doesn't go in evenly, right? So y divided by x is not a constant. Therefore, it is not proportional. Plus, I mean, all you have to do, once you know it doesn't go through 0, 0, it cannot be proportional. All right, so that's your quick check right there. All right, but if we take a look at the change in y over the change in x, what's happening here? That one's plus 4, that one's plus 4, that one's plus 4, that one's plus 4, that one's plus 2, plus 2, that one's plus 2, that one's plus 2. So the change in y over the change in x is 4 over 2, which simplifies to 2. So we have a constant change, rate of change. So that is our slope. That's what makes it linear. So it's linear but non-proportional, right? Linear but non-proportional. And if we were to graph those points, we would get a straight line. So let's skip over here. Make a table of values. This is like what we've been doing, right? So they give us this equation. Again, I can look at each of these and see they are non-proportional. Remember, y equals kx is going to be proportional. Y equals mx plus b is going to be non-proportional. So here we go. 2 times negative 2. That's negative 4 plus positive 5 is 1. 2 times negative 1, negative 2 plus 5 is 3. 0 gives me 5. 1 is going to give me 7. 2 is going to give me 9. And again, take a look. It does not go through 0, 0. That proves it's non-proportional. Plus, 9 divided by 2 is not the same as 7 divided by 1, which is not the same. But if you look at the change in y, plus 2 plus 2 plus 2 plus 2 over the change in x, plus 1 plus 1 plus 1 plus 1, that is a constant. Change in y over change in x is a constant. That's what makes it linear, but it's not proportional. Okay? All right, so if you take a look at this line, do you see how it's a straight line, but it doesn't go through 0, 0? So it is non-proportional. So why is this one non-proportional? It does not pass through the origin 0, 0, right? How about this one? How do we know this one's not proportional? Well, 7 divided by 2. Remember, we're going to check y divided by x. 7 divided by 2 is 3.5, right? 11 divided by 4 is not 3.5, and we don't even have to check any of the other ones. So y divided by x is not a constant. Therefore, it's not proportional. Also, all right, it does not contain 0, 0. Proportional relationships, that must be a 0, but it's not, so it's not proportional. All right, so I hope you have a pretty good idea now of what makes something proportional, what makes something non-proportional. This one is going to be non-proportional because it is y equals mx plus b. If we put in negative 2, we get negative 3. So just a reminder, negative 2, negative 3, we could graph right there. Negative 1, we get negative 2. Negative 1, negative 2 would be right there. 0 would be negative 1, right? 1 would be 0. And 2 would be 1, right? And you see how those form a straight line, but that straight line does not. That straight line does not. Did I mention that that straight line does not pass through 0, 0? So it's a linear, but non-proportional. It misses the origin right here, right? Here we go. It's not 0, 0. It's a 0, negative 1. So linear, non-proportional, y equals mx plus b. All right, one more thing I need to go over, and then we will be done. All right, this idea of sometimes we should connect the points with the solid line, and sometimes we shouldn't. So if you look at what I just did, I made the points from the table, right? These were the points from the table, but then I went ahead and connected them with a solid line. And the reason why is because I could put a point here. Couldn't I put in a half, right? And a half minus 1 would be negative a half. And so right here, I could put a point right there, couldn't I? Right? Or I could do 1 and a half. Well, 1 and a half minus 1 would be a half. So 1 and a half would be right there. So do you see how I could fill this in with whatever I wanted? I could do negative 3 and get negative 4. Negative 3, negative 4. Actually, negative 3, negative 4 would be right there. So I could fill in whatever I wanted from this equation. X could be anything. But there's some times where it doesn't make sense for x to be anything. So if you take a look at here, we have the relationship between the number of $4 lunches you buy with a $100 school lunch card. All right, well, if you think about it, all right, it's going to be y equals 100 minus 4x, where x is going to be the number of lunches, right? And y is going to be the amount left on the card. So if you buy 0 lunches, then you have $100, right? If you buy one lunch, then you have $96. If you buy two lunches, then we need to take $4 more away. We get 92. Three lunches, we take $4 more away. We get 88, and so on, right? And if we were to graph that, we would have some points going down, but we shouldn't connect them. And the reason why we shouldn't connect them is because you're not going to buy part of a lunch. You're not going to buy a fractional part of a lunch. So state whether it should be solid or unconnected. This one should be unconnected. And the reason why is no fractional parts of a lunch. Okay? Now, if we look at this one over here, the relationship between time and the distance remaining on a 3-mile walk for someone walking at a steady rate of 2 miles per hour, right? So if I did that one, that would be y equals 3 minus 2x, all right? But in that case, can you walk part of an hour? So y would be the distance left, right, or the distance remaining, and x would be the number of hours. Now let me ask you a question. Can you walk for part of an hour? And the answer is yes. You can walk for 30 seconds. You can walk for 3 minutes and 25 seconds. So this one could be solid, right? And the reason is there are fractional parts of an hour are okay, right? A fractional part of an hour would be a minute, and a fractional part of a minute would be a second, and a fractional part of a second would be what, a millisecond or whatever, okay? But you get the point. So sometimes when you make a graph, you're going to make points that you don't connect. Sometimes when you make a graph, you're going to plot those points, and then you're going to draw the line through them, all right? Sometimes what I will do is I will make a dotted line. Those of you who watched the video with the bowling problem with Jake and Aaron, I made dotted lines because you can't have or you can't pay for part of a game of bowling, but I like to show the trend with the line. But if they ask you, is it solid or connected, think, can we have a fractional part of that x? That's what it is. Can you have a fractional part of the x? And of course, when you have a fractional part of the x, that will lead to a fractional part of a y. You actually could have a fractional part of money left on the card, but you're not going to pay for a fractional part of lunch. They're not going to sell you half a lunch for $2, right? They're not going to sell you a fourth of a lunch for $1. You get a $4 lunch, and it goes down by fours. Does that make sense? All right, well, I hope that makes sense, and I hope now you have a pretty decent understanding of linear, non-proportional relationships. As always, thanks for watching this video, and until next time, see ya.